Witam wszystkich serdecznie. Welcome everybody. I will just switch to Polish for a few minutes to explain everything. Witam serdecznie na kolejnym SpeleoWebinarium, pierwszym, które odbędzie się w języku angielskim, ponieważ mamy po raz pierwszy gościa z zagranicy, który przyjął nasze zaproszenie. I proszę się nie obawiać, to nie będzie tak, że każde następne webinarium będzie prowadzone po angielsku. Któreś webinarium, jeżeli uda nam się zaprosić kogoś, to będziemy jakby wykraczali poza nasze granice. Natomiast dzisiaj zaczniemy. W razie jakichś problemów proszę Państwa o komentarze. Oczywiście zapraszam do zadawania pytań na naszym czacie i pozwólcie Państwo, że przerzucę się na angielski. Welcome everybody on the 26th SpeleoWebinarium, and the first one, which is in English. Our guest today is the one and only Lukas Plan.
Hello, everybody.
Hi. I guess most of you know Lukas, but just a short introduction. Lukas is an Austrian speleologist and a caver. He holds PhD in geology. In his PhD dissertation, he worked on karst surface processes and karst hydrology in Hochschwab region. And since then, he studied cave development in the Eastern Alps, both the epigenic caves and hypogene caves. He worked on neotectonic in caves, in dating and landscapes, and many other karst and speleology aspects. And hence he's a well-known caver and speleologist and geologist. And he, of course, also explored caves, mostly in Lower Austria, in Hochschwab, but also in Todesgebirge and Dachstein. And today he will tell us, he will review the knowledge about deep caves in Austria, deep and long caves in Austria, and not only from the caver point of view and visiting them point of view, but also from the origin point of view. So, okay, Lukas, floor is yours.
Okay.
Start your presentation, please. Yeah, it works. You can. Oh, and of course, sorry, just one more thing. On the right side, you can see the chat. So please ask any question you like Lukas to answer after the presentation. So yeah, now floor is yours.
Okay, thank you for the invitation and for the introduction. You asked me to a little bit present the long and deep caves of the Eastern Alps. So the first part is rather for the cavers and for friends of long caves, of numbers, of deep caves. And I try to pick out some interesting spots. And the second part will be how these caves developed, how old are they, and especially how where the water came from that formed these caves. Short geographic introduction. So I'm sitting here in Vienna. Vienna, as you can say, is the eastern end of the Alps. What you can see here is the Alps, Salzburg, city of Salzburg. Here's the bar, 25 kilometers, Graz in the south. And the rivers are the Danube, main rivers, Danube, Enns River, and the Salzach River. And already from this image, you can see quite different landscape pattern. You see this rather dendritic river network in the, let's call it Central Alps or Austro-Alpine crystalline. So these are metamorphic rocks. And then you see these plateaus of the so-called Northern Calcareous Alps. And mainly in this presentation, I will focus on the Northern Calcareous Alps, which are more or less this part of the Alps. We will mainly talk about the Northern Calcareous Alps, which I just told you. And the plateaus are the Dachstein here. It's almost 3,000 meters high. Todesgebirge is the biggest karst massif in Austria. It's almost 60 kilometers from east to west. Tennengebirge you maybe heard of. Hoher Göll is well known to Polish cavers. Hagengebirge, Polish cavers are active. Untersberg at the border to Germany. And then Leoganger Steinberge, of course, you know, Lambrechtshofen. And yeah, and far more to the east, Jacek already told, where I'm mainly exploring at the moment, the Hochschwab area. And also these are karst massifs close to Vienna, Rax and Schneeberg, where Vienna gets its water from. Here again, it's not a geological map, but the map, I'm sorry, this is in German. So with the karstic rocks. So the blue one is limestone. Here again, you see Todesgebirge, Dachstein. Magenta are dolomites. Then you have mainly limestone, but also some marls is the light blue. And the greenish stuff here, only small patches of carbonate rocks, is metamorphic rocks. So it's marble. But mainly we focus on the Northern calcareous Alps, which is this region. Now we zoom into the central part. Here you see a nice overview over Todesgebirge, this karst plateau with the summits around 2,000, 2,500, the Hohe Priel, meters above sea level. And here you see again the karstic rocks, limestone, and you nicely see that the distribution of caves, the yellow dots are small caves, 5 to 50 meters, and the red dots are 500 to 5 kilometers, and there are few pink ones, which are caves longer than 5 kilometers. And you nicely see that this distribution of dots, distribution of caves, correlate mainly with the limestone. Of course, you have few caves in dolomitic rock or in this marl or mainly carbonatic rocks, but most of them are in the limestone. And almost all of the limestone is Triassic. Only a little bit of Jurassic limestone is of minor importance, and mainly Upper Triassic Dachstein limestone. Also, everything you can see on this picture is Dachstein limestone from the Upper Triassic. So it's about 220 million years ago it was deposited. Once again, aerial photograph from Todesgebirge with the lagoonal fascias of the Dachstein kalk, which makes these nice bedding plains. And then this was eroded by the glacier, and this makes this typical Schichttreppenkarst, staircase pavement, I think is the English word. So all these steps are caused by bedding planes in the Dachstein limestone, and they are normally 1 or few meters, maybe 5 meters, sometimes 10 meters high. Let's have a look at the caves. The longest cave system in Austria is the Schönberg. I abbreviated HS for Höhlensystem, means Schönberg cave system. I will often use this HS because all the long caves are called cave systems or are composed of several caves, so they are cave systems. And yeah, and has a depth of a bit more than 1,000 meters. It's in Todesgebirge. Later on we will see a map, and quite often you have some very nice big galleries or chambers, sometimes a little bit coined by breakdown. It's also very labyrinthic parts of that cave, extremely dense mazes, and this is in the deep parts. You are in the zone that gets flooded every year or during high water. Up to 50 meters the water table rises here, but you have very nice galleries, and it's completely clean, no sediments. There are quite high flow velocities, so no sediments are deposited in parts of that deep sections of Schönberg Höhen system. This is the deepest point, a sump 750 meters below the entrance you used to get here. Here's an overview. So Schönberg Höhen system is composed of two cave systems. For many decades they searched for a connection and finally found it some 15 years ago between Raucherkarhöhle and Feuertal Höhlensystem. And here you see the section with a very high entrance, Kachelschacht, and then most of the cave, let's say 70, 80, whatever percent, are around 1500 meters above sea level. And there is this lower section. Here is a picture from approximately here, lower section, which is hydrological active. So these levels are quite old. We don't know how old. In that case, in other caves we know it, but they are fossil, and only there are some vadose streams crossing that old phreatic galleries. But probably they are some or several million years old. And this is a view from the summit of Schönberg. Mount Schönberg is 2,070 meters. The summit is 2,070 meters above sea level to the southeast, and this is Lohse, and here is Schwarzmooskogel, and here is the second longest cave system in Austria, the Schwarzmooskogel Höhlensystem. Yeah, this is the nice karst plateau. Again, you can see the bedded Dachstein limestone, and this is enemy of the cavers. Let's say this is the Mugo pines, dwarf mountain pine, Pinus mugo, and if you want to go here in the middle of mugo pines, it's really annoying and makes caving much harder than it would be without these plants. Yeah, impressions from Schwarzmooskogel cave system. It's 138 kilometers long, and the depth is also a bit more than 1,100 meters. And this is a very famous, the so-called snow volcano chamber, Schneevulkanhalle, which is said to be the biggest ice chamber, at least in the Eastern Alps. And here's a cone, snow cone. There's a shaft entrance. It's filled up with snow, and then these ice stalagmites. Some of them are 8, maybe 10 meters high. Quite impressive chamber. The cave has quite long history of exploration. Here you see inscriptions from 1948. Some parts of the caves are quite easy, and presently it's mainly explored by British cavers and cavers from Germany. And it's also consists of several cave systems: Schnellzughöhle, Schwarzmooskogel, Eishöhle, Kaninchenhöhle, Steinschlagschlacht. So they were all connected. And also the strategy at the moment is to find new entrance and then go down several hundred meters and then connect it to the main system. And one part already almost goes down to the level of a nearby lake, Lake Alter See. It's already in the flood zone of nearby springs that get where the water level rises by 50 meters, so 50 meters above the lake level. Some impressions. Of course, not all of the galleries are that big, but in this cave you quite often have some 50, 60 degrees steep ramps where the galleries, inclined phreatic shafts are developed. Yeah, this is overview showing the location of Schönberg Höhlensystem and Schwarzmooskogel Höhlensystem, and of course it's a big dream to find a connection of the cave. So currently there are 2.6 kilometers missing in between, which looks quite a lot. But if we also look at the other known caves in between, so there's Ahnenschacht, for example, this blue one here, and it's almost, I think it's just a matter of 1 or 2 years that Ahnenschacht will be connected to Schönberg system. And also, as I told you, the strategy of the British cavers is to find a new cave, go down several hundred meters, make a connection, and then, so maybe sooner or later, it will be one big cave system. So here to Nanoschacht, which is in a plausible distance from Schönberg system, is only 1.5 kilometers. And with the current numbers, it would give, if we sum up Schönberg system, Ahnenschacht, and Schwarzmoskogel system, it would give a length of 320 kilometers. Yeah, here is just an impression, Ahnenschacht. It was already explored by Belgish and French cavers in the 70s, if I'm correct, and is being resurveyed at the moment. And yeah, actually they also found a lot of new passages, and within the last 5 years, 20 kilometers of that cave were documented. From the eastern part of Totesgebirge, it is not far to Dachstein. It's only across the valley, the Traun Valley, and this is the summit. Dachstein, as I told you, is the highest peak in this huge plateaus of the Northern Calcareous Alps. It's almost 3,000 meters high, and so it's to be correct, it's 2,995 meters, and it's the only plateau with a major glacier. So all of these plateaus have been glaciated during the Pleistocene cold periods, and only Dachstein presently has a significant glacier. This is Lake Hallstatt and the village of Hallstatt, which is known for salt mining for at least 5,000 years. They were mining salt here, and this is the entrance of Hirlatshöhle, which is the third longest cave in Austria. It's 180 kilometers, and the depth is 1,560 for some years now. Again, nice phreatic gallery. All of the 3 long systems which I showed you, or I'm showing you, are almost entirely developed in Dachstein limestone. Yeah, you can walk through the cave for many hours in galleries like this. Sometimes half an hour without any obstacle, just walking up and down. Some parts are dry, but you will see that there are narrow, nasty parts as well. This was, let's say, the key to the cave. Cave was known since the 1950s, and then for many years it was only 8 kilometers long. And then they climbed the chimney and made a traverse and continued the climb. So in total, it's almost 300 meters you have to go up. And then there was a major breakthrough to discover new galleries. And in some parts are technically quite challenging, because you have to traverse lakes, and or diving was done there in very remote parts. So a lot of easy walking, but the distances are quite far. And in 2018, there was a successful connection. Hirlatshöhle is accessible from the valley, let's say, the old parts, and then there was a sump, maybe some 8 hours from the entrance, and they explored, made a post-sump exploration, but then stopped at the chimney. And in 2018, it successfully was connected to the what you got pot, or just WUG. You go down 700 meters and then a lot of horizontal stuff, and then they made the connection to Hirlatshöhle, which made it 1,560 meters, the second deepest cave in Austria. These are pictures from the What You Got pot made by Axel Hack. Very nice, typical this Pleistocene clay with the desiccation cracks. If it's dry, it's nice, but if it gets squeezy and this clay becomes wet, then it can be very nasty. And really sometimes exploration stopped because of that clay. This is the team that made the connection, British Cables. Hillard-Höhle, the classical part of Hillard-Höhle is mainly explored by Austrian cavers, and What You Got pot was more or less entirely by British cavers and some help of Germans and Austrians and international support. Yeah, here's an overview, Hillard-Höhle. This is the main entrance. This is a spring. You can it goes 60 meters below the level of Lake Hallstatt, and then here it connects to the main part of Hillard-Höhle, and this is the entrance at the plateau, What You Got pot, and connection was somewhere here with Hillard-Höhle. And this is also the biggest vertical extent in Austrian cave. It's 5.7 kilometers in the plan view, the maximum extension. As I told you, exploration was not continuous, but the cave was found in the 50s. Here you have the time scale and the length of the cave, and then after 7 or 8 kilometers, it was more or less constant until the breakthrough in 1983, and then it was more or less like an explosion. Within 1 year they surveyed 20 kilometers, and this was the connection with the What You Got pot, again a jump in the length of the cave. Now we go to the south side of the Dachstein. We have seen Dachstein summit before from the north. By the way, this is Totes Gebirge in the background, and this is the huge Dachstein massif with the glacier we have seen from the other side. And there are two interesting caves, the Voodoo Canyon, where you have to upside 150 meters in the southern cliff of Dachstein, and below there is Südwandhöhle, which I will show you some impressions now. This is a geological section with the caves. So I told you Hillard-Höhle is more or less entirely developed in Dachstein limestone, which is the gray color. And below Dachstein limestone, there is dolomite. It's called Wetterstein dolomite. So it's Middle Triassic dolomite. Is this light violet color. And Südwandhöhle, only the entrance part is in limestone, but then the most parts of the cave, and this is an exception in Northern Calcareous Alps, has developed in dolomite. And there's also a chance that there will be a connection from Voodoo Canyon to Südwandhöhle, but there's a major breakdown, and so far they didn't find a connection. In general, as Kessel goes below level of Lake Hallstatt, and Dachstein is almost 3,000 meters high, Dachstein would have a maximum depth potential of 2.5 kilometers. So theoretically, if you connect these two caves, and then there was dye tracing, so they put color in a stream in Südwandhöhle, and it was going to the north, so at least hydrologically, there should be a connection between Hillard-Höhle and Südwandhöhle. So maybe one day, but that's very far. That's dream. So I think I will not be able to witness that these caves are connected in my lifetime. Yeah, some impressions from Südwandhöhle, huge galleries, 20 meters wide, 10, 15 meters high, here at persons for scale, and entirely in this dolomite. It's a really lousy rock, but yeah, you have these huge galleries. And on the other hand, it's also the cave with the most rock overburden. You have 1.2 kilometers of rock above the cave. That's also outstanding figure in Austrian caves. So if you're here to the Dachstein summit, more or less, it's 1.5 kilometers of rock above the cave. Clara Höhle, I want to show for two reasons. So you have seen that most of these caves, there is almost no speleothems, no dripstones, no decoration. Okay, you have some isolated part, but an outstanding cave is Clara Höhle. It's 30 kilometers long. It's in Sengsengebirge, which is northeast of Todesgebirge. And it really has outstanding decoration. It's maybe the catchment area is not as high as Dachstein, so there is more vegetation. You can have a higher carbonic acid that can dissolve more limestone and not precipitate it in the cave as dripstones. There is one, maybe the highest stalagmite. It's 18 meters high in an Austrian cave. In Clara Höhle. Also quite big chambers, and this is also an exception. This is not Dachstein limestone, but it's Middle Triassic Wetterstein limestone, the host rock of this Clara Höhle. Here is a list of the longest caves in the Eastern Alps. So 3 caves longer than 100 kilometers, and at the same time they're also deeper than 1 kilometers, and a total of 21 caves longer than 25 kilometers. We have seen Schönberg Höhlensystem, Schwarzmoskogel, Hillertshöhle, and Ahnenschacht. We have seen an impression, and the only cave, which is all of these caves are in Austria, except Riesending Schachthöhle, which has entrance, and most parts of the caves are on the German side of Untersberg, but it also reaches below Austrian territory. So that's also an exception. Where are these caves? This is a distribution of these caves longer than 25 kilometers. Most of them we have seen, most of them are in Todesgebirge, and the 2 long ones, Schönberg Höhlensystem, Schwarzmoskogel Höhlensystem, Dachstein we have seen, Hillertshöhle, this is Dachstein Mammuthöhle, Tennengebirge, Hagengebirge, then Riesending, Untersberg, Lambrechtsofen, and this is Koltbläser Monster Cave System. And only 2 of these caves are further to the east. One is in Lower Austria in the Ötscher Höhlensystem, it's 27 kilometers long. And one is in Hochschwab, also in Wetterstein Dolomite, the Fraunauer cave system, which is 45 kilometers approximately now. Let's have a look at the deepest caves in the Eastern Alps. There are 19 caves deeper than 1 kilometer. Again, only one of them has the Riesending again with the entrance in Germany. So Austria has 18 caves deeper than 1 kilometer. And Lambrechtsofen, of course, well known among Polish cavers, is the deepest cave, and worldwide it's the 6th deepest cave with 1,727. I will focus on Lambrechtsofen. I will not tell a lot about Lambrechtsofen. There are not to a Polish audience, because most of the caves, all these parts have been explored by Polish cavers, Andrzej Czyżewski, and only the lower parts were explored by cavers from Salzburg. Another outstanding cave is Feichtner Schachthöhle, also explored by Polish, because this is the only cave deeper than 1,000 meters which is not in the Northern Calcareous Alps, but it's in some calcareous mica schist, so it's a metamorphic rock. You can see completely different rock texture, which is in the Austro-Alpine crystalline and not in the Northern Calcareous Alps, where the rocks are not metamorphic. I will now jump to newcomer, Steinbockschacht. It's the only deep cave I'm personally involved in the exploration, and last September a depth of 1,127 meters was reached. It's a mainly vertical cave with drops. This is the bottom of a 250 meter deep direct shaft. The bottom is around minus 600. And here you see a section through Hochschwab. It's not that steep. This is 2 times vertically exaggerated, so you have to imagine that it's in reality it's only half as steep or as high. But you can nicely see that it's only vertical cave. There's maybe only 50 meters in the upper part where you can walk, but everything else is more or less vertical and penetrates very nicely into this massive. And these are speculations how deep the cave. So we have not reached the sump yet, or we have reached the sump, but there are parts going deeper, dry parts going deeper. And this is speculation. With the gradient from the spring, I assumed 3 degrees. We already, if the inclination of the water table is 3 degrees, we would already have reached it. But it could also be that it's only 0.5 degrees, and then we have another 200 meter maybe. But I guess 100 meter are quite realistic of depth potential until we reach the water table. So again, the distribution of the deep caves, most of them in the central parts of the Northern Calcareous Alps. Todesgebirge, 4 of them, Dachstein, 2 of them, I think 6 or 7 in Tennengebirge, Hoher Göll, very relatively small mountain explored by Polish cavers. Jacek is one of the explorers. Has two of these deep caves, Untersberg, Riesending, and Kolbradhöhle, and then the deepest one, Lamprechtsofen, on the Leoganger Steinberge, which don't exhibit this typical plateau character like Dachstein or here's Steinernes Meer, for example. And the outliers, let's say the Feichner Schachthöhle in the Austria-Alpine crystalline, and the newcomer in the list of the 1 kilometer deep caves, the Steinbockschacht at Mount Hochschwab, much further to the east. So this was more or less the first part of my talk, and the second part is not about Swiss Army knives, but on speleogenesis and the question how these big systems in the Northern Calcareous Alps developed, how old they are, and so on. And these are quartz grains, and they are important for estimating or for dating the caves. There is a method, it's called barrel age dating, where you when the quartz grains are not, they don't have to be exactly at the surface, but close to the surface, several meters, cosmic rays can penetrate into the rock and will produce aluminum and beryllium, aluminum 10, beryllium 26. And these are both radioactive and with different half-lives, and will, so over time, the ratio of these two, at the beginning, the ratio of aluminum and beryllium is constant. And as soon as the quartz grains are shielded from cosmic rays, so if they're washed into a cave system and buried deep underground, due to the differences in the half-life of these isotopes, this ratio of aluminum and beryllium changes, and you can calculate the age of the, or not the age of the quartz, but when the quartz was last time exposed to cosmic rays. And it's a very expensive and time-consuming method. And so far there exist some 20, 30, many of them are unpublished dates on this quartz grains. And I forgot to tell you that they are called Augensteine because they look like eye stones. They look a little bit like eyes and are known for a very long time. But they are not part of the stratigraphic sequence of the Northern Calcareous Alps. They were brought from the south of the Northern Calcareous Alps, and this will already concern us in the next few slides. So here are some results published by Heuselmann et al. 2020 from Dachstein Mammuthöhle at around 1,400 meters above sea level, which is 900 meters above the local base level, which is the Lake Hallstatt. We have already seen when we were talking about Hydrology. And so approximately you can say that the method has quite a big error. You're with 5 or 6 million years, you're already at the limit of the method, but we have several ages suggesting that these caves around 14, 15, 1600 meters above sea level are around 5 million years old. And in the geologic time scale, this is the late Miocene or early Pliocene. And from the depths to the base level and the age, you can also calculate how fast the mountains were uplifted, or at the same time the valley were incised into the mountains, and you come up with 180 meters per million year, which you can also express like 100 or let's say 0.18 millimeter per year. So if you or 1 millimeter in 5 years, let's say, approximately. So, which is caves are with that respect, caves are very important because from the surface is always changing, so you cannot get such figures from surface geological observations. That's why these caves are very important for the reconstruction of the former landscape, of the polar landscape. Similar dates were gathered from Eiserriesenwald, about 1,700 meters above sea level, and there is one date of a little bit younger, 3.3 million years, but it's only one age and it could change. And also Tantalhöhle is quite similar, with around 4.7 million years, plus minus 0.5 million years at around 1,500 meters. And the next question is puzzling people already for more than 100 years. We have seen, where did the water come from that was responsible for the development of the big systems in the Northern Calcareous Alps. And this is a nice drawing by Hermann Bock from 1913. And he postulated that these are the Northern Calcareous Alps, and south of the Northern Calcareous Alps you have a big catchment area, streams or small rivers entering the karst and flowing underground, and then emerge again on the northern side. So streams were flowing through the Northern Calcareous Alps. And this was taken up by other authors like Haseke Knapczyk in the late 1970s. Michael Denneborg, Philipp Audra also postulated that there was a through flow of water from the south of the Northern Calcareous Alps through the Northern Calcareous Alps. And the arguments were that you have these allogenic sediments, these Augensteine, which can only be brought from the south of the Northern Calcareous Alps. Then you have the huge passage dimensions, and sometimes the location of the caves and the paleoflow directions, and also the paleoflow direction I will now discuss. These are features also related, very often related to quartz grains or to unsoluble material. It's called paragenesis, and these are sealing meanders, and they develop if you have a profile, a phreatic profile, then the profile is filled with, almost entirely filled with sediment. Then between the sealing and the sediment, the unsoluble sediment channels will develop and will small channels will grow into the sealing, and later on there's a big flood or whatever, ice age, a lot of water comes, removes all the sediment, and you see these sealing meanders. In German they are called Beckenkarren, and here in some caves, especially in Todesgebirge, they are very prominent features of the caves. This is the paragenesis, and here, for example, you have remnants of the sediment glued together by calcite. So this gallery was completely filled with sediment, and between the sealing and the sediment, these channels eroded. This is on the small scale, and if the gallery is not completely filled with sediment, but if sediment only occupies the floor of the gallery, then the sediment, the gallery will grow upward. Also, the sediment pile will grow, and you can produce very big profiles. But actually, they were never used, or probably never used. The water never used the whole section, but only small portions of it. So this is from Dachstein Mammuthöhle, where the whole cross section is 100 square meters, and only maybe 20% of it was used by the water at once. Coming to the Paleoflow, how did that's a question that puzzles me for several years now. How did the water flow in the cave? So if you don't have any layers that control the flow direction of the water, you have to rely on indicators in the cave, and this could be so-called speleogenetic phases. So if this is a section of Schönberg Höhlensystem, and you can see that they are inclined to the north by about 0.5 degrees. But there are indicators in the cave as well. These are scallops, called scallops. These are quite long, or normal scallops, let's say, about 10 centimeters. If they are shorter, like these ones, only 1 centimeter, the water flow was much faster. Yeah, and they are asymmetric, which shows you the flow direction. So in this picture, it was from, or in all of these pictures, it's from right to left. And here, nice Polish caver. And here, the scallops are much longer, approximately half a meter or almost 1 meter. Also, sediments can show you the flow direction. If you analyze the long axis of the sediments, they show a certain direction. That's the direction which they are stable in the water flow. So if axis would be like this, water flow is from right to left, the pebble will turn and then it's in the stable position. This is called imbrication. So these indicators can tell you how the water flow was. And we did that in detail. We analyzed a lot of caves. These are symbols for the scallops with the flow directions. We analyzed also others, but I don't want to go into detail. And this is a map of Eisriesenwald with an overview of the Paleoflow, and then you can get overall Paleoflow direction from this analysis. So Eisriesenwald, for example, flow was from the southeast, from the southwest to the northeast. And to reconstruct Eisriesenwald, it was from the entrance, the cave rises, and so this was always an argument that the entrance was a former spring, but the scallops clearly show that water flow was into the cave. So you can reconstruct that it was kind of a sump, the rising part of a sump, And this part is, in the meantime, in the last probably 5 million or 3.3, we have seen age of ice Riesenwelt, maybe. This part was eroded, and now you find this uprising. You walk if you enter ice Riesenwelt, you walk with the Paleoflow direction of the water. We did that. Jacek was also involved. The Paleoflow analysis for Hirdatshöhle also gave northeast directed Paleoflow, and also for Schönberg-Höhlensystem to check if it's really this could be also tilt of the cave within the last 5 million or whatever few million years. The cave could have been tilted, but in most cases, only for one part, it's not true. But in most cases, this Paleoflow in these scallops indicate the same direction as this inclined surfaces do. Only the recent parts, the youngest parts, they show an opposite flow direction. Almost coming to the end of my presentation. Here again, you see the map of Todesgebirge, Dachstein, and Tennengebirge. Here is the margin of the Austro-Alpine crystalline, where the quartz pebbles came from, and the arrows indicate the Paleoflow direction. So for Tennengebirge, it's the nicest, quite sure that water came from the Eastern Alpine crystalline, flew to the north. Also for Dachstein, it's rather north directed. But for Todesgebirge, it looks different. It's more chaotic, or rather shows a radial Paleoflow direction. So from the margins of the plateau out of the karst massives. And another map showing the abundance. That's just an impression how obvious is paragenesis, and it also shows that for Todesgebirge, most caves are completely covered by paragenesis, and there is only few sections which don't show paragenetic features. Whereas in Dachstein and Tennengebirge, it seems to be not that abundant. However, if we look at the abundance of Augensteine, of these quartz pebbles, we see that they are quite frequent in Dachstein and in Tennengebirge, except for Bergerhöhle, but this is much lower, and the lower caves normally don't show that many Augensteine. But in Todesgebirge, they are either completely missing or quite rare. So presently, I assume that Dachstein, Tennengebirge had a Paleoflow through the karst massive from the south to the north, bringing all that gravel through the caves to the north. But Todesgebirge rather had this radial flow, and Augensteine are just derived from the surface. They are older. Rivers were flowing above the karst massives in Eocene, Oligocene times, deposited the Augensteine, and later they were washed into the caves, but not by streams flowing through the massives. This is a summary of my presentation. The Northern Calcareous Alps are very rich in long and deep caves due to the quite massive, up to 1 or 1.5, sometimes 2 kilometers of the limestone, and with the dolomite, several kilometers of Triassic carbonates. 3 caves are longer than 100 kilometers and deeper than 1 kilometer at the same time. I think worldwide there are only 7 caves that have this exceptional lengths and depths. So for a very small country like Austria, it's quite exceptional, I would say. We have seen the age of the caves. The majority of the caves, like these galleries, are between 1,300 and 1,700 meters above sea level, and they are roughly 5 million years old. For Todesgebirge, we don't have data yet, but next week with Jacek, we go to find some Augensteine, and maybe next year we can tell you how old caves in Todesgebirge are. There are major differences in the cave sediments and their impact on the cave morphology. We've seen these paragenetic features, which are for many caves in the Northern Calcareous Alps are quite omnipresent. Allogenic recharge, so the water was coming from outside the Northern Calcareous Alps, is very likely, at least for some parts of the Northern Calcareous Alps. But in general, there was no uniform through flow as postulated formerly from the south to the north, no through flow to the Northern Calcareous Alps, only for some plateaus. And for example, for the Todesgebirge, presently I would postulate rather radial Paleoflow. Yes, thanks for your attention. I hope it was not too long. Pictures were stolen from these people, and in the field I was accompanied by a lot of people, but especially these ones I want to thank. This is not exploration, this is rather for the scientific work. Thank you.
Thank you very much for the overview of both the cave exploration and the science. And we're waiting for some questions now. Hopefully they will appear in a second. Just a quick update on your deepest 1,000 meters deep caves. There is 20 now, not 19. The Kammsteighülle system.
Sorry, I forgot. Oh,
no worries. Just
I updated an older presentations and I forgot. Yeah, that's
no worry.
3 caves in Huagöl. Yeah.
3 caves in Huagöl since last August. Yeah.
There are several comments.
Sorry?
There are already several comments, but most
of
them I cannot read.
Okay, so Christos asked.
Hello.
Christos asked, what do you think about the main drive of the paragenesis phase?
It has to be a climatic phase that allows a lot of sediment to be washed into the cave. And in Todesgebirge, I didn't mention that I mentioned it's not Algensteine, but it's mainly Jurassic chert. It's mainly radiolarian from the upper Jurassic. I hope that
But do you mean Christos?
Climate and tectonic control? I don't. It's too much speculation. I don't want to.
Do you think it's somehow connected with the, I don't know, glacier melting and like the?
No. It's
much younger.
It's much older. Glaciation is much older. Yeah. I think the paragenesis was at more or less from the beginning of the speleogenesis. Sediments were present, and for most caves or for many caves, we could show that the sediments that is responsible for paragenesis, you find that the sealing is most probably the oldest sediment. So I think it's from the early phase of it's not a later reshaping of the cave, but it's from an early phase. Yeah.
Okay. And I have a question about you mentioned that this you mentioned ages you recently obtained from the beryllium aluminum dating, and you showed some results about 5 million years from this so-called giant cave level around 1600 meters. And my question is, do you have any older ages you can share from the Ruinenhöhle, so from the uppermost level, recently, last year, there was a paper from French Alps where they the age of 11 million years, almost the mid-Miocene. And of course, I guess we expect that the Iranian cave, the oldest cave level is also mid-Miocene, let's say, around 10 million. But do you have actually any dates or not yet? Or
no.
share because it's unpublished?
No, I don't have any dates. No, there's just I didn't go into detail with the cave levels. If you want, I can do so. I have some slides. So if you this is not so nice, but if you look at the distributions of the caves in the massives, you can see that they are mainly, let's say, 90% of the caves in general are within a 3 to 4, in Dachstein 5 distinct levels. And this ruin cave level, the blue one, around, let's say, around 2,000, 2,200 meters above sea level, there is only a rough estimate, let's say, or a correlation with landscape development and the paleogeography that they developed already in Eocene, Oligocene time, so maybe some 35 million years ago.
Okay.
Presently, there is no method to really prove that or for dating these caves. We have a hint from Dachstein, from a cave from the ruin level, where we found in the sediments we found lateritic minerals that can only develop during very humid tropical climate. And the last time such climatic conditions, this was at least some 15 million years ago, during the mid-Miocene climatic optimum or in Eocene Oligocene time. So normally from the beginning of Miocene, it was, except for this mid-Miocene climatic optimum, it became colder. So this sediments in the ruin cave level, and we didn't find these sediments in lower caves in lower cave levels. So this could be a hint that the caves are really at least 15 million years old.
Okay, thank you. And there is a question from Branislav Schmida. Do you think that is it possible to connect Schönberg-Hüllen system and Schwarzmuskogel-Hüllen system?
Yes. I think it's possible, but if it's 10 years, if it's 20 or 30 years, I don't know. So yeah, in both caves, they work quite hard. And especially what the British do, or also the Austrian cavers in Schönberg-Hüllen system, new cave, connect, and then, so from one entrance, it's not possible, but you have to walk into the plateau, go down 200-300 meters, whatever, and then try to connect caves. Okay. I'm quite optimistic, but it will take some decades.
Looks far though.
Not in the next 5 years. I'm quite sure.
Okay. Are there any questions? I can't see anything. Okay, so once again, Lucas, thank you very much for
the invitation,
lecture and sharing all your knowledge with us. And I can invite you, everyone. I mean, the next SpeleoWebinarium will be more classic one in Polish, and it will be about the exploration in Picos de Europa in Spain. Nice. So by Polish cavers. So it will be in Polish though. So see you next month, or of course see you in some time if you are an English-speaking person. We will organize in a few months another SpeleoWebinarium in English about some other topic from abroad. Okay, thank you very much and good night. Bye.
Bye-bye.